Teacher, how do you do cross product? Cross product? Don't know. Cross product. Hey, what that is, teacher? Can't even tell what is cross product. Just define what is cross product.
Have no fear, teacher is here, and today we will solve an equation. Our equation today is about the distance between the line and the point. As you can see, if you can imagine a point and a line and a distance from each other, this we call it vector v. If we imagine a point on vector v, we name P with the coordinates 0, 0, 0. We can form a vector from P to the point which we can name point S, and this would give us PS. To find the distance from the point to the line, we have to find this section. And this is also called P sine, PS sine theta, with theta being here. Okay, so from previous unit, we know that P sine theta we can derive from the cross product and derive a new formula, which is and that is how you find the distance from S to the line V. Welcome back. Alright, now let's try and do a question on how to find the distance from a point to a line segment. Okay, the question states that there is a point S in space with coordinates 0, 0, 12. And there is a line with parametric equations x equals to 4t, y equals to negative 2t, and z equals to 2t. Okay, as you have learned from the previous subtopic, we can derive a line vector from the parametric equations. And this is v equals to 4i minus 2j plus 2k. And this is our line vector. And also, we have to imagine a point on the line vector, which is this one, and we give that point the name P. P. This point has to have the coordinate 0, 0, 0 to make things easier for us to find. Okay, now let's draw it all out so that you can imagine it a little bit easier. There's a point in space called S with coordinates 0, 0, 12, and a vector V with the vector equation 4i minus 2j plus 2k. Alright, so now I told you, as I said, you have to imagine a vector, a point on the vector P with the equation 0, 0, 0. So now we have to form a vector from P to S. And to calculate the vector, we take the second point minus the first point, which would give us 0, 0, negative 12 in component form. So this is the vector PS. As I said earlier, the distance formula which I showed you is equal to PS cross V over magnitude of V. Alright, welcome back. Wait. Before we move on, I bet you thought I made a mistake, didn't you? You wanted that 1 mark, didn't you? Well, never. So, from the previous few minutes, you have seen that the vector V and the S can be drawn out in this form to help you visualize the distance D. Alright, so now D is actually from the point S perpendicular to the line V. And since we have our PS, our vector PS to be 0, 0, 12, and our vector V to be 4, negative 2, and 2, we can substitute them into this formula to find the answer. And here now, as you have learned in the cross product unit, we have to use the matrices rule. Okay. Alright, welcome back. Okay, when you equate this, you should get the answer to be 24I plus 48J. And this is PS cross V. However, we need the magnitude of this, and so we can find it to be 24 square root 5. So now that we have PS cross V, we can substitute this into the formula, which is this. But hold on, we still need to find the magnitude of the vector V. And since the vector V as given earlier was 4I minus 2J plus 2K, the magnitude would be root 4 squared plus 2 squared plus 2 squared, which gives us 24. And all we have to do is substitute all this into the formula. PS is 24 root 5 over root 24. And finally, we have the answer to be 2 root 30. And this, just to remind you, is a scalar quantity, and this is the distance D between the point S and the line V. Thank you. Alright guys, so now I have one question for you. Do you understand? Is that a yes or a no? No. Yeah.